Hello everyone, welcome to yet another session based on Scikit-Learn. Today we are going to generalize how Scikit-Learn workflow is, basic programming intuition behind it, and then we'll cover the first step of every machine learning problem solving methodology, that is, making sure data is clean and generalizable. In more technical words, this step is called pre-processing. So by the end of this session, you'll understand the workflow of Scikit-Learn and how you can carry out data pre-processing. I hope the agenda for this session is clear to all of you guys. But before we get started with this session, please make sure that you hit the subscribe button and bell icon so that you never miss any update from Intellipaat YouTube channel. Okay, that being said, let's dive into this session and talk about how Scikit-Learn workflow is. Now, if we guys talk in most basic sense, the Scikit-Learn workflow begins with some sort of data. You then eventually provide that data to the model, and this model will learn from provided data and then it will further be able to make predictions. That's the general workflow in the most basic sense. But that's quite vague. So let's go a little deeper. Now, what do we mean by giving a dataset to the model? Typically, if we have a dataset that is useful to make some predictions, we split it into two parts. And the common notation to call this splitted data is one to call x and other to call y. Now this x here is something that is representing everything that I'll be using to make predictions. What I mean by that is this x will contain the features of an event that will describe the outcome of that specific event. For example, heavy rain, false drainage system are the features that will lead to events such as waterlogging. That means the outcome here is waterlogging and rain plus faulty drainage system are the parameters responsible for that event. Now, y in our case will be the output data. I mean, it will contain the result which will occur on a given set of parameters. For example, let's say I have an iris dataset. Now, in this dataset, I'll have the class of plant as my target variable and features such as sepal length and width as well as petal length and width acting as parameters which will describe the type of plant. Now our model should find patterns in these features which make the particular plant belong to a certain category. But before that, we'll feed this x and y data to our model. Then we'll train the logical ML algorithm over this provided data. Basically, we'll fit our data to this model. But before I talk more about that, let's visit our code editor and get ourselves a dataset that Scikit-Learn provides. The dataset will be the same, I mean the iris one, whose use library. So for that purpose, let's visit the code editor. Now let me import this Scikit-Learn library. The command to do that is import sklearn and I'll run this block. Now to get our dataset, we have a command and that command is from sklearn dot datasets import load underscore iris. So iris is basically a dataset that is already stored inside sklearn library. So we will be importing it using this load iris method. So let's run this block as well. Now next we'll visualize how this data looks and for that we'll just write load underscore iris command and this will actually load the data on our code editor. So let's run this. Here you can see that there are input variables and there are some target variables as well. Alright. And this is the information about our dataset. Now if I want to visualize x and y separately, then I can do that by adding return underscore x underscore y to the previous functional argument. So I'll copy this command. I'll add the argument that we just talked about, that is return underscore x underscore y and I'll run this command. Oh wait, so I'll have to set this true as well. Now here you can see that both the input features and the output feature has been separated clearly. Now moving forward, we'll be storing this data for future computation in variables of our own. Let's say those variables are again x and y. And to sort of store this data in these x and y variables, we'll have to use the load command again. So we'll use x comma y stores load underscore iris and return underscore x underscore y equal to true. And we'll run this block. And with this successful execution, I can say that I have feature data and output data separated in x and y variables. Okay, now we have data in a format that can be fed to a machine learning model. To sort of get an overview of the procedure, we'll actually formulate a model. But before that, we should conceptually visualize what a machine learning model actually does. And for that purpose, let's go back to the presentation. Now, when you create a model initially, it's not directly fed with data. The model creation involves two steps in Scikit-Learn basically. We first create or generate a model, and then after that we make the model learn our data. In Scikit-Learn, all models are just Python objects, and then this learning over here in Scikit-Learn terminology is often denoted with .fit methodology. During this typical step of .fit, we actually pass the set of variables that we have termed as x and y, representing the feature data and output. Now remember guys, our model must pass through both of these phases so that it can make the prediction. Now that being said, I hope that you guys have collected some intuition out of this. Let me take all of you back to the notebook in order to show you how easily the said notion can be coded. Okay guys, there is one more thing I want you guys to be clear of. Now the problem that we are dealing with here right now is the classification problem. In this problem, we have to classify our rows into different plant classes, right? Well, we'll be talking about the concept of classification later on in this series. But for now, let me tell you that we can use models like linear regression, KNN or SVM to solve these classification problems. Now, first, let me pick up the linear regression model. To call an object of this model inside a notebook, I'll have to write a command that is from sklearn dot linear underscore model import linear regression. Now I'll run this block and I'll take new one. Now for the model creation stuff, what I'll have to do is I'll have to create a variable named model and assign this called object to it. That means what I'll do is I'll create new variable and I'll put this function linear regression into it. So let me do that. Now I'll run this block and you can see that the model has been created. Now guys, this is the phase where model is not learning anything. Here we are just creating it. So this is the first stage that we talked about. So if I were to call a method model.predict right now, it must return an error. Let me check that. So if I call model.predict over the data samples x, and if I run this statement, I must get an error, and see we are getting it here. And so for dodging this error, all we have to do is fit our model to the data. For that purpose, let me take a new block. Here, what we'll do is we'll fit our data. And for that, we have a command named as fit. And we'll pass x and y to it. Yeah, you can see that our model is being fit with linear regression object or algorithm. Now once this step is done, the model will pick up patterns from the dataset. This time, when I try to call the predict function, our model will be able to make some sort of deductions. For right now, we are not going to discuss what this machine learning model actually does, cause our priority right now is to understand the overview of ML modeling workflow. Well, one more thing guys, the best thing about Scikit-Learn is that API for all the machine learning models will remain the same. I mean, we just created the linear regression model. Similarly, the API structure will prevail for all other models. Well, before that, let me actually see if this model is predicting the output or not. So I'll use model.predict function and I'll pass x to it. And it must produce some output that matches with y. So guys, here you can see that we are getting some sort of predictions. Alright. Now this was the one model. What about other models? Well, let's say I want to create one more ML model, that is k nearest neighbor. So the first thing I'll do is I'll invoke the k nearest neighbor classifier object. And for that I'll use the command that is sklearn dot neighbors import k neighbors regressor. And now I'll store this inside the new variable and I'll run this block. Now in the next step, I'll fit our data to this new algorithm. So mod dot fit x comma y, and I'll run this. Now our k nearest neighbor regressor will generalize over the provided data, and to check if it is making right predictions or not, I'll use the prediction method. So I'll use mod.predict over the input data and I'll run this block. Now guys, you can see that this is actually making very close predictions, right? So let me also show you the output data. See, here it is. So it is actually making very close predictions. Now we'll talk about the structure of this algorithm laterwards and why linear regression perform bad on this particular use case. But for now on, let's just focus on the workflow of this modeling technique. Now guys, we just saw the predicted data and the given output data and we made a comparison. But what if I want to visualize this data? What can I do? Well, for that purpose, I'll have to import the matplotlib library. The matplotlib library contains lot of graph plotting techniques that will allow me to plot graph for the predicted data and the actual data. So for that purpose, I'll be using scatterplot here. Now what I'll do is I'll put predicted values on x-axis and given output values on y-axis. So let me code this quickly. Import matplotlib as plt, then predicted data is equal to model.predict x, and then I'll plot the scatter graph, and I'll pass predicted data on x-axis and y on y. That is our output variable, right? So let me run this block. And guys, by looking at this graph, you can see that the predictions we have made and given output matches in all the scenarios. What that means is our model has learned the pattern in data accurately, which means there is good signal and low noise. But this might not prevail with every dataset or the problem. We'll discuss more about how models work and how to choose the best model. But for now, this is the basic structure of machine learning solution buildup in its very basic sense. But guys, keep this in mind that this is not how a typical machine learning problem works, or this is not how the typical machine learning problem should be coded. The data you get might not be well optimized, and there might be a degree of difference between measurements. And data like that cannot be fed to the machine learning model. That adds one more layer to our machine learning procedure, that is data cleaning and pre-processing. So moving forward, we'll take a deep dive into the concept of this data cleaning and pre-processing. So guys, basically every machine learning exploration begins with exporting a dataset. In the last demo where we understood how the Scikit-Learn API works, we directly imported the Scikit-Learn dataset and stored it inside one variable. But this time I'll show you how to store dataset inside a data frame. Now if you guys are wondering what exactly is this data frame, then let me make this clear guys. Data frame is a unique two-dimensional data structure implemented in Pandas library of Python. I mean, it contains rows and columns like SQL tables or a spreadsheet. In terms of programming, you can visualize it as a dictionary of a series of objects. Alright. Okay, now that being said, the first thing we'll have to do is import the Pandas library. The command is quite simple. Import pandas as pd. And I'll run this block. Now next is getting our data to store inside the data frame. The dataset we are going to use is the Titanic dataset. Now again, this is the dataset that's part of Scikit-Learn framework and it is commonly used for learning and data exploration purposes.
If you want to make a career in data science, Then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
So guys, to load this dataset, we'll have to import one functionality, that is fetch underscore openml. Now the command to do that is from sklearn dot datasets import fetch underscore openml. Now I'll run this and it will import the fetch openml functionality. Next, we'll import our dataset using the fetch openml function and we'll store it inside the data frame. So how can I do that? Well, df is equal to fetch underscore openml, the dataset that I'm going to load, that is Titanic, and I want to use actually a very specific version of this dataset, that is version 1, and I'll set as underscore frame equal to true, and we'll be taking it as a data, right? Okay, now let's run this block and check if our dataset is imported and stored inside our data frame or not. For that purpose, we'll use the command known as df.info. So let me write that command quickly. And here you can see the information about our dataset. So basically our dataset contains 13 columns, right? And all of them are basically non-null values, right? At the bottommost part, you can also find out the data types that are part of this dataset. Here you can see that we have 2 categorical variables, we have 6 float features, and then we have 5 object type features. Now let's find out if there are missing values in our dataset. The pandas function we have for this purpose is .isNull. So let me use that function quickly, df.isNull, and I'll run this. And here you can see that it is highlighting the areas where our dataset contains null values, right? So wherever it is true, that means there is a null value inside that row or that particular column. Alright guys, so this is not actually a better way to visualize, right? So for that, I'll calculate the overall null values inside each column, and the command to do that is very simple, df.isNull.sum. So I'm summing null values across every column. Alright, so let's run this command, and here you can see that there are like 263 null values in edge column, 1014 null values in cabin column, 2 null values in embark column, 1188 in body, and same for home.dest and body. Now the data type here is integer 64, that is the numbers returned here are integer obviously. Now the question that should strike your mind is, how significant are these null values and is it necessary to dodge them? Well, let me help you guys visualize this with help of an graph. For this purpose, we'll be using the Seaborn library. So let me first import it. So I'll import Seaborn library with command import Seaborn as SNS, and I'll run this block. Now the library has been imported. After importing, I'll also set the graph styling with the help of set function in Seaborn. So sns.set, then we'll calculate the missing value percentage for each feature. Now how can we do that actually? Well, what we'll do is we'll divide the number of null values entries by the number of rows in our dataset, and to convert it into percentage, we'll multiply it by 100. And let me put that in a programming syntax here. So it will look like miss value percentage will be equal to pd dot data frame df.isNull dot sum divided by the length of df. Alright, and I'll multiply it by 100. Now the next step will be the plotting graph. We'll plot it as a bar graph and we'll keep the percentage on y-axis. Okay, so the command I'll use for that is miss underscore value percentage dot plot. Kind of graph I'm going to use, it's again, as I mentioned, bar. Then the title that I want to give to this graph, that is missing values, and then y label, that is percentage. All right, so let me run this block, and here you can clearly deduce that we do have multiple null entries. Now the problem with that is, if we don't have appropriate data, our model won't be able to learn properly, right? For example, consider you don't have any study material and suddenly your faculty takes your examination. Will you be able to perform great in that examination? You won't be, because you won't know the concepts, right? And same prevails for machine learning, and this will actually lead to scenario where our model will make very blunt predictions and will have very less accuracy score. So we'll have to find a resolution to add something in place of these missing values, or drop the entire feature so that it won't affect learning adversely. All right, so first let me walk you guys through the concept of dropping a feature. Now in our entire data set, the body feature has the most null values, as you can see here, right? So what we'll do is we'll drop this column. We'll print the size of dataset. The function we have for that purpose is dot shape function. So the command for printing the shape will be print the size of a dataset df dot shape. All right, now I'll run this command and we'll get the shape of our dataset. All right, that means there are 13 columns and 1309 rows. All right, now I want to drop one column, right? So let me move ahead with that. The command for that will be df dot drop, which is the function that is used to drop the column, and inside it I'll pass the column that I want to drop, that is body, and I'll set axis equal to 1 so that it will remove the column. If I set axis is equal to 0, then it will actually remove the row. All right, and I'll set in place equal to true, and then I'll enter another printing statement where I'll print size of the data set after dropping column, dropping a feature, let's say, and again we'll pass the same df.shape argument, and let's run this block. All right, so here you can see that one column has been removed. All right, now the in place argument that we have added in this drop function is something that will keep true, right? So what this does is it tells the interpreter that make sure the changes that we have done are being converted into permanent changes. Basically guys, pandas shows the data frame with changes we make, but it will not modify the original data frame df. And to make sure that df is updated, we use this in place argument. All right, okay, I hope so this strategy is clear to all of you guys. Next we'll look into another method, that is value imputation. So guys, deleting feature is never preferred, because by removing a column we're actually missing one reason which causes the course of outcome or which contributes towards the output, right? And we don't want to see that happening, because our model won't be able to generalize properly otherwise. In scikit-learn, we have simple imputer class which can help us impute missing values quite easily. This simple imputer is a very convenient strategy for missing data imputation. It replaces all missing values with a statistic calculated from the other values in a column. This strategy can often lead to impressive results and avoid discarding meaningful data when constructing your machine learning algorithm. The statistics that this imputer uses are mean, median, and mode. These three methods compute the numeric output out of available data to replace null values, and by making use of them, it has been observed that machine learning models perform very well and become capable of generalizing a new set of data. So first of all, let us import the simple imputer into our notebook. And for that, let me visit the code editor. Now I'll take a new block of code and I'll impute this simple imputer. And the command to do that is from sklearn dot impute import simple imputer. Alright. Now we'll impute the values for the age column here. Alright. First of all, let me print the number of null values in this column. So the statement I'll write is print number of null values before imputing. And I'll pass this df dot age is null some argument. Alright. So what this will do is this will return the total number of null values inside this age column. Alright. So let me run this command. And here you can see that there are 263 null values inside this age column. Alright. Next we'll create simple imputer instances. But before that, let me tell you about the arguments it includes. So basically it includes three important arguments. The first one is missing values. The missing values is a placeholder which has to be imputed. I mean basically it is the null value in our dataset. By default it is set to be NaN, right? Then we have second argument, that is strategy. The data which will replace by NaN values from the dataset is known as statistical strategy. The strategy argument can take values such as mean, median, most frequent and constant. And then we have third important argument as fill value. The constant value to be given to the NaN data using the constant strategy should be mentioned in fill value section. Alright. Now here we'll use the mean strategy. Alright. So the way to invoke this simple imputer is that create a new variable and invoke it. Simple imputer and set the strategy to mean as we have mentioned. Now we will apply this transformer that we have just generated to the age column with fit underscore transform method. So what fit underscore transform method will do is it will fit our data to this imputer and it will generate the non-null values to replace the null values, that is NaN values. Alright. So command I'll write for that is df age equal to impute dot fit underscore transform df column age. Alright. Now next we'll print number of null values in age column after imputation. Alright. Passing argument will be basically the same. So we'll copy it and we'll paste it here. Now let me run this block. And here you can see that there are 0 null values inside age column right now. What that means is we have successfully imputed values for our age column. Okay guys, I hope this is clear to all of you now. Now let me show you guys how we can impute missing values for this whole dataset. Well, what we'll do is we'll figure out parameters differently by defining one Python function separately. The reason behind doing this is pretty simple guys. The dataset contains different data types, some of which are even string format, and computations like mean, median or mode cannot be achieved on string data, right? Hence we need to program this separate function that will allow us to visualize what sort of elements are inside our dataset, right? Okay, so let me define this function as get underscore parameters. So def get underscore parameters and I'll pass df as an argument. Inside this function, I'll create the parameters dictionary. After this, I'll create for loop and I'll iterate through the columns of our data frame. I'll choose the column that contains null values, right? So the command for this will be for column in df dot columns and we'll choose null columns, right? It's null dot any. Now if df column dot d type, that means the data type of entries inside that column, is equal to float 64, or if df column dot d type is equal to int 64, or it is equal to int 32, then set strategy equal to mean. Alright, so if we have the numerical variables, then definitely we can use mean as strategy, right? Otherwise, what we'll do is, else we'll use strategy as most frequent. Alright, so let me run this part. So there is no bug in this much part. Now we guys have decided this strategy, but there is one more problem, guys, that needs addressing. In Python, when we deal with mixed data types, columns are converted into ND-array format in broadest upcasting. So to dodge that, we'll create a custom missing value array. Actually, we'll create a 2D array containing column and null type. So for that, we'll actually have to figure out missing values as well. So I'll create the new variable named as missing underscore values, and I'll set df column dot is null dot values 0. Now similarly, the parameters dictionary will store missing values as parameter that we created in last line, that is again a missing value, and strategy will be strategy, and will return the parameters. And now let me pass the argument and run this block. The argument should be get underscore parameters and df as an argument. Alright, so let me run this block quickly. Yeah guys, there was an indentation error in our block, so I have removed it. Now here you can find out that there are missing values and there are different strategies, right? For k-bin we have none as missing value and strategy will be most frequent. For embark, missing value will be nan and strategy will be most frequent again. For fair, the missing value will be nan and strategy will be mean. And same different strategies for different columns. Alright, so now we have got the parameters. Alright, so let's make use of them and actually predict the values, right? The first thing we'll do is we'll store this parameter dictionary into a new parameter variable which will be available outside the local scope of previous function, right? So the way to do that is define new parameters and store these parameters inside it. I'll run this command. Okay, next we'll iterate through the parameter dictionary. We'll set missing underscore values and strategy depending upon the data type of each column, and then we'll pass it to the simple imputer. Let me do that quickly here. So for column comma parameter in parameters dot items, missing values equal to param missing values, strategy will be equal to, that is stored inside our parameter. Now we'll import the imputer, and for that purpose the command I'll write is import imputer equal to simple imputer, and I'll set missing values equal to missing values itself, the variable that we just abstracted from this parameters dictionary, and strategy which we also have gotten out of this parameters dictionary. Now I'll fit our data to it. So df call, that means all the columns inside our data frame.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
Will be fitted to this simple imputer using fit underscore transform method, and will only perform this over column matrix. Alright, so now let me run this block. Yeah, it's successfully compiled. And finally, let me also print the sum of null values inside our data frame. So df.isNull.sum, and here you'll find out that there are no more null. Wait, so let me run this again, and you'll find out that there are no null values inside our data set right now. Next, we have feature engineering. So guys, feature engineering is the process of selecting, manipulating and transforming raw data into features that can be used in supervised learning. In order to make machine learning work well on new tasks, it might be necessary to design and train better features. As you may know, a feature is a measurable input that can be used in a predictive model. It could be the color of the object or the sound of someone's voice. Feature engineering, in simple terms, is the act of converting raw observations into desired features using statistical or machine learning approaches. Now, I'll show you the example of feature engineering, but before that, let me show you how our dataset looks. So, I'll use df.head command here, which will show us the way our data looks. Alright, so here you can see these two columns, right? SIB-SP and PAT. So SIB-SP is the feature in our data set that captures the number of siblings passengers have traveled with, and PAT captures the number of parents and children that the passenger traveled with. So we can use feature engineering to infer the person traveled alone or by with his family by looking into these two parameters, right? And for that we'll have to combine these parameters. So let me put down what I have said in context of program real quick. So what we are gonna do is we are gonna check if the person has traveled alone or with family. So we'll merge these SIB-SP and patch columns together. So for that, df family will be equal to df SIB-SP plus df patch. Now if df dot loc dot df family, so inside the data frame, the location where df column is, if the row's value is greater than 0, then the person will be considered as traveled alone. And the value will be set to 0. Alright. And similarly, if df.log is equal to 0, then traveled alone, and the value that will put will be 1. Now df traveled underscore alone value underscore counts dot plot title equal to passenger traveled alone, and the type of graph we want to show will be bar. Now I'll run this block. There is an error, guys, so let me check this error. Okay, so here we have used the double square box. Maybe because of that we are getting this error, so I'll remove it and I'll run the code. And yeah, here you can see that we have the data where passenger traveled alone and when he did not travel alone. So guys, this is how you're supposed to carry out feature engineering and create a meaningful parameter out of the very raw parameters that are provided to you. So this was all about the notion of feature engineering. Now the next point I have on my itinerary is encoding features into format that can be fed to the machine learning model. Now, when dealing with classification problems, you need to encode categorical features numerically on a continuous scale. The Scikit-Learn API requires categorical features code editor. First, I'll import the one-hot encoder from sklearn. Then I'll set. So guys, the column that we are going to transform with one hot encoding is 6. So basically we have two sexes in our data set, that is female and male. So female and male are both in textual format. We want to convert it into binary format. So for that we'll use these two characters and this sex column itself. So we'll set female comma male equal to one hot encoder dot fit underscore transform df sex column, and we'll convert it to the array. Now let me show you how this is achieved here. So what we want to print is sex, then the female and the male. So this will generate encodings for both sex, female and male parameters. So let's visualize how it looks. Yeah, here we are getting an error, that is data frame object has no attribute to array. That is true. So all I have to do is take this to array out from here. Guys, the reason behind this error is, again, we are dealing with a column, so we'll need to add one more box brackets. We'll add them and we'll run this code. This is working fine. Here you can see how one hot encoding looks like. But this is quite redundant, isn't it? All this information could be stored in single column where female is 0 and male is 1, right? To do so, we'll select the male column from the array resulting from the fit underscore transform method. So what we'll do is, we'll create the new coding block and inside it df6 will be one hot encoder dot fit underscore transform. Inside it again we'll pass the 6 column and we'll convert this whole thing to array so that it will be saved in a column format. Alright, and to save it in a column format, I'll have to pass this as an argument. With this indexing, we can say that the format our data will be stored inside df6 column will be in a tabular column wise format. Alright, so now let's run this command. So we haven't converted this into a method, so that was the error. Now the next thing will be visualizing the data. So let me show you how one hot encoding looks. Now here check out the 6 column, guys. So here you'll see that 6 column has been replaced with zeros and ones. So now zeros will be men and 1 will be female. Alright. Now I hope this one hot encoding part is clear to all of you guys. After this we have data scaling. So if the data in any condition has data points far from each other, scaling is a technique to make them closer to each other. Or in simpler words, we can say that the scaling is used for making data points generalized so that the distance between them will be lower. As we know, most of the machine learning models learn from the data by the time the learning model maps the data from the input to output. And the distribution of the data points can be different for every feature of the data. Larger differences between the data points of input variables increases the uncertainty in the result of the model. The machine learning models provide weights to the input variables according to their data points and inferences for output. In that case, if the difference between the data points is so high, the model will need to provide the large weight to the points, and in final result, the model with a large weight value is often unstable, right? This means the model can produce poor results. This means the model can produce poor results or can perform poorly during learning. I'm not saying that all the algorithms will face this problem, but most of the basic algorithms like linear and logistic regression, artificial neural networks, clustering algorithms with k values, etc., face the effect of the difference in scale for input variables. Scaling the target value is a good idea in regression modeling. Scaling of the data makes it easy for model to learn and understand the problem. In the case of neural networks, an independent variable with spread of values may result in large loss in training and testing and cause the learning process to be unstable. For example, one feature can contain data in pounds and other in kilograms. To interpret properly, these features need to be on same scale. They should be at least in kilograms or they should be at least in pounds. So that is the reason why we need data normalization. To normalize the data, we can use two methods that are available in Scikit-Learn, that is standard scaler and min-max scaler. Let's first talk about min-max scaler. For each value in a feature, min-max scaler subtracts the minimum value in the feature and then divides by the range. The range is the difference between original maximum and original minimum. Guys, basically this min-max scaler preserves the shape of original distribution. It doesn't meaningfully change the information embedded in the original data. Like you can see the graph over here, right? So what it does is it converts it into range of 0 to 1. Alright? That is all you need to remember about min-max scaler. Next we have standard scaler. Standard scaler follows the standard normal distribution. That is, it assumes a normal distribution for data within each feature. The scaling makes the distribution centered around 0 with a standard deviation of 1 and the mean removed. For a data sample x, its score for standard scaler is calculated as xi minus mean of x divided by standard deviation of x, which is mean is represented with mu and standard deviation is presented with sigma sign. And again, the mean can be forward calculated using this formula and standard deviation can be calculated using the formula given here. Alright guys, now I'm not gonna talk about the mathematical details about both of these techniques. I'll simply show you how you can implement these scaling methods in Python program. Alright, so let me visit the code editor to do that. Now first thing first, let me import the standard scaler to our notebook. For that we have command from sklearn dot preprocessing import standard scaler. Alright, I'll run this command. Now the next step will be selecting the numerical columns cause we can only scale numerical columns, right? So let me find out the numerical columns first. For that I'll create the new variable named as numerical columns and inside it I'll store the selected data type columns, that is int 64, float 64 and integer 32, and I'll print these columns. So let me run this. Here you can see that these are the numerical columns we have in our data set. Now what we'll do is we'll apply our standard scaler. Alright. So first of all I'll invoke the object of standard scaler using the syntax new variable is equal to standard scaler. Alright. Now I'll run this command again. Next I'll create new data frame which stores the num columns, that is numerical columns, and I'll apply ss.fit underscore transform method, and again I'll pass all the numeric columns. Now dot describe, and I'll run this. Now here you can see that all the values has been standardized. All these values are between 0 and 1's proximity. Alright guys, now all of these values are in log format. So if you convert these values into simple numbers, you'll find out that these values lie between 0 and 1. So this is how standard scaler works. Now let me also show you how min-max scaler works. Now we'll import the min-max scaler. So the command for that is from sklearn dot preprocessing import min-max scaler. Now after that we have already found out the numerical columns. So we'll again call that num columns variable that we created previously. So right now all we need to do is we'll need to pass this min-max scaler to some variable so that it will be invoked, and then df.num underscore columns will be equal to min-max dot fit underscore transform. Again we'll pass num underscore columns and we'll print the columns. But guys, we have already applied standardization to this data, so I don't know how these values will be. Well, they are quite nice, alright, because the data was previously standardized itself. So because of that, our min-max scaler is putting it into more perspective, alright. So these values are quite processable, and if we feed them to the network machine learning model, it will be able to produce some sort of very accurate prediction which is close to our output parameter. Alright, now I hope this min-max scaler and standard scaler is clear to all of you guys out there. Let me tell you that this was just an overview of how data can be handled. Okay, we'll be carrying out more such operations down the line throughout this series. So with this session, just try to build a basic intuition for this pre-processing process. Alright, and I wish to thank you all of you guys for being here till the end of this session. I hope this session was informative and enthralling. You have liked this video, a thumbs up would be much appreciated. Also, if you have any concerns about this said concept, then please put them in the comment box below. Our 24/7 team of experts would be obliged to resolve all of them for you guys. Also, make sure you are subscribed to the Intellipaat YouTube channel so that you never miss upcoming multiple updates.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.